Static routing. Static route with an exit interface. Configuring a static route with an exit interface. Let's investigate another way to configure the same static routes. Currently, our 1S static route for the 192.168.2.0/24 network is configured with the next hop IP address of 172.16.2.2. In the running configuration, note the following line. IP route 192.168.2.0, 255.255.255.0, 172.16.2.2. As you will recall from the previous section, this static route requires a second routing table lookup to resolve the 172.16.2.2 next hop IP address to an exit interface. However, most static routes can be configured with an exit interface, which allows the routing table to resolve the exit interface in a single search instead of two searches. Static route and an exit interface. Let's reconfigure the static route to use an exit interface instead of a next hop IP address. The first thing to do is to delete the current static route. This is done using the no-ip-route command as shown in the figure. Next, configure our 1S static route to 192.168.2.0/24 using the exit interface serial 0/0/0. Then use the show IP route command to examine the change in the routing table. Notice that the entry in the routing table no longer refers to the next hop IP address but refers directly to the exit interface. This exit interface is the same one that the static route was resolved to when it used the next hop IP address. Now, when the routing table process has a match for a packet and this static route, it will be able to resolve the route to an exit interface in a single lookup. As you can see in the figure, the other two static routes still must be processed in two steps, resolving to the same serial 0/0/0 interface. Note, the static route displays the route as directly connected. It is important to understand that this does not mean that this route is a directly connected network or directly connected route. This route is still a static route. We will examine the importance of this fact when we discuss administrative distances in the next chapter. We will learn that this type of static route still has an administrative distance of 1. For now, just note that this route is still a static route with an administrative distance of 1 and is not a directly connected network. Static routes and point-to-point networks. Static routes that are configured with exit interfaces instead of next hop IP addresses are ideal for most serial point-to-point networks. Point-to-point networks that use protocols such as HDLC and PPP do not use the next hop IP address in the packet forwarding process. The routed IP packet is encapsulated in an HDLC Layer 2 frame with a broadcast Layer 2 destination address. These types of point-to-point serial links are like pipes. A pipe has only two ends. What enters one end can only have a single destination, the other end of the pipe. Any packets that are sent via our 1S serial 0/0/0 interface can only have one destination, R2S serial 0/0/0 interface. R2S serial interface happens to be the IP address 172.16.2.2. Note, under certain conditions, the network administrator will not want to configure the static route with an exit interface but with the next hop IP address. Modifying static routes. There are times when a previously configured static route needs to be modified. The destination network no longer exists, and therefore the static route should be deleted. There is a change in the topology, and either the intermediate address or the exit interface has to be changed. There is no way to modify an existing static route. the static route must be deleted and a new one configured. To delete a static route, add no in front of the iproot command, followed by the rest of the static route to be removed. In the previous section, we had a static route. iproot 192.168.2.0, 255.255.255.0, 172.16.2.2. We can delete that static route with the no iproot command. No iproot 192.168.2.0, 255.255.255.0, 172.16.2.2. As you will recall, we deleted the static route because we wanted to modify it to use an exit interface instead of a next hop IP address. We configured a new static route using the exit interface. iproot 192.168.2.0, 255.255.255.0, serial 0/0/0. It is more efficient for the routing table lookup process to have static routes with exit interfaces, at least for serial point-to-point outbound networks. Let's reconfigure the rest of the static routes on R1, R2, and R3 to use exit interfaces. As you can see in the figure, as we delete each route, we will configure a new route to the same network using an exit interface. Verifying the static route configuration. Whenever changes are made to static routes, or to other aspects of the network, verify that the changes took effect and that they produce the desired results. Verifying static route changes. In the previous section, we deleted and reconfigured the static routes for all three routers. Remember, the running configuration contains the current router configuration, the commands and parameters that the router is currently using. Verify your changes by examining the running configuration. The figure shows the portions of each router's running configuration that show the current static route. This figure shows the routing table for all three routers. Notice that static routes with exit interfaces have been added to the routing table and that the previous static routes with next hop addresses have been deleted. The ultimate test is to route packets from source to destination. Using the ping command, we can test that packets from each router are reaching their destination and that the return path is also working properly. This figure shows successful ping outputs. Ethernet interfaces and ARP. Sometimes the exit interface is an Ethernet network. Suppose that the network link between R1 and R2 is an Ethernet link and that the fast Ethernet 0/1 interface of R1 is connected to that network, as shown in the figure. A static route, using a next hop IP address for the 192.168.2.0/24 network, can be set using this command. iproot 192.168.2.0, 255.255.255.0, 172.16.2.2. As discussed in the previous section configuring an Ethernet interface, the IP packet must be encapsulated into an Ethernet frame with an Ethernet destination MAC address. If the packet should be sent to a next hop router, the destination MAC address will be the address of the next hop router's Ethernet interface. In this case, the Ethernet destination MAC address will be matched to the next hop IP address 172.16.2.2. R1 checks its fast Ethernet 0/1 ARP table for an entry with 172.16.2.2 and a corresponding MAC address. Sending an ARP request. If this entry is not in the ARP table, R1 sends an ARP request via its fast Ethernet 0/1 interface. The Layer 2 broadcast is requesting that if any device has the IP address 172.16.2.2, it should respond with its MAC address. because R2's Fast Ethernet 0/1 interface has the IP address 172.16.2.2, it sends back an ARP reply with the MAC address for that interface. R1 receives the ARP reply and adds the 172.16.2.2 IP address, and the associated MAC address, to its ARP table. The IP packet is now encapsulated into an Ethernet frame with the destination MAC address found in the ARP table. The Ethernet frame with the encapsulated packet is then sent out the Fast Ethernet 0/1 interface to router R2. Static routes and Ethernet exit interfaces. Let's configure a static route with an Ethernet exit interface instead of a next hop IP address. Change the static route for 192.168.2.0/24 to use an exit interface with this command. IP route 192.168.2.0, 255.255.255.0, Fast Ethernet 0/1. The difference between an Ethernet network and a point-to-point serial network is that a point-to-point network has only one other device on that network, the router at the other end of the link. With Ethernet networks, there may be many different devices sharing the same multi-access network, including hosts and even multiple routers. By only designating the Ethernet exit interface in the static route, the router will not have sufficient information to determine which device is the next hop device. R1 knows that the packet needs to be encapsulated in an Ethernet frame and sent out the Fast Ethernet 0/1 interface. However, R1 does not know the next hop IP address and therefore it cannot determine the destination MAC address for the Ethernet frame. Depending upon the topology and the configurations on other routers, this static route may or may not work. We will not go into the details here, but it is recommended that when the exit interface is an Ethernet network, you do not use only the exit interface in the static route. One might ask, is there any way to configure a static route over an Ethernet network so that it does not have to use the recursive lookup of the next hop IP address? Yes, this can be done by configuring the static route to include both the exit interface and the next hop IP address. As you can see in the figure, the exit interface would be Fast Ethernet 0/1 and the next hop IP address would be 172.16.2.2. IP route 192.168.2.0, 255.255.255.0, Fast Ethernet 0/1, 172.16.2.2. The routing table entry for this route is shown in the figure. The routing table process will only need to perform a single lookup to get both the exit interface and the next hop IP address. Advantages of using an exit interface with static routes. There is an advantage to utilizing exit interfaces in static routes for both serial point-to-point and Ethernet outbound networks. The routing table process only has to perform a single lookup to find the exit interface instead of a second lookup to resolve a next hop address. For static routes with outbound point-to-point serial networks, it is best to configure static routes with only the exit interface. For point-to-point serial interfaces, the next hop address in the routing table is never used by the packet delivery procedure, and so it is not needed. For static routes with outbound Ethernet networks, it is best to configure the static routes with both the next hop address and the exit interface.